Hey guys, welcome back to the channel. I know it's been a while, but let me kick things off right off the bat. No, I haven't stopped making new videos. I did, however, step away for one major reason, namely the ChaseBuddy. Now, everyone who's ever chased storms before know how fragmented everything is. Like you have a tool for radar, you have a website for satellite, and then another thing for lightning, and then another apps for observations and storm data. Like it's massively inefficient, it's messy, and when you're out in the field, it actually slows you down at the worst possible moment. That's why we started building one unified platform, like a true storm chasing companion designed to put everything in one place. And that's exactly where the name the ChaseBuddy comes from. During my first video, it really dawned on me how much my content would improve with the full platform behind it. Like not just some basic overlays, right? But a proper tool for analysis, exploration, explanation, and storytelling. So instead of pushing out more videos with those limited tools, I chose to pause a little bit for a while and focus on building the ChaseBuddy, which will help me in my storm chasing anyway, right? And this is actually the main reason why the app was built. Help us in our storm chasing activities. So today, for the first time, I'm actually going to show the app that I have been creating with two friends of mine, Bart de Vriend and Michael Vragen. Bart de Vriend is an excellent tech lead. Michael Vragen is a brilliant developer. Me, myself, I am a software architect where I provide geographical solutions for our client, or geographical software solutions for our client. Put those three minds together and you have a very good basis to actually build the app that I'm now going to showcase to you guys. So without further ado, let's dive straight in and see what the ChaseBuddy is all about. So guys, before I dive straight into each of the products, let me just give you a quick overview of the interface. As you can see here, like this is the core of the ChaseBuddy, a clean, fast, responsive map that everything else is built around, right? On the left side here, you have the side menu. This is where all your layers are located, like radar, as you can see, satellite, lightning, model data, observations, storm tracking, space weather, and then your shooting locations, right? Everything is right there in one place. In the middle at the bottom, you have your playback controls and your color scale for the radar. More about that in a minute. You can currently pause the loop, you can play the loop, you can go to the next frame, previous frame, first frame, or last frame. Now at the top right, you have your standard map controls, zooming, panning, perspective change, and a day and night theme, which you can activate. At the bottom left, there's a button you can use for your shooting locations. More on that in a minute as well. And here at the right, you have a toggle which shows some settings. Momentarily, there's only radar settings in there, but the settings will gradually increase. The more features are going to be added into the product itself. So the entire layout is built to stay fast, rather intuitive and practical, especially during storm chasing events. All right, so now we've covered the overview. Let's dive a little bit more straight into each of the layers, what they represent and what you can do with them. So guys, let's start with the radar. Right. If you open up the radar menu, you get a toggle for enabling the radar sites. As you can see here, orange ones are the ones that are active, blue ones are the ones that are inactive. Inactive can mean anything, like the radar site itself is down due to maintenance, or there's a problem with the data gathering, or whatever. You can also toggle the radar imagery itself. You can zoom in, you can zoom out, as you can see here, right? If you actually want to change the radar image, you just tap a radar site and you can choose between reflectivity or velocity. Currently, we only have like two products. We only have the base reflectivity and the base velocity. More products will be added in the future, but yeah, you need to start somewhere. So you click on a radar site, you get these options, you say, okay, I want the reflectivity, the whole reflectivity loops for that radar site. Pick another one. It's the exact same idea. Currently, we only provide a loop for the latest 2 hours of radar imagery, each frame being 5 minutes apart. Both for reflectivity and velocity, this is the case. Okay, if you pick a product or if you pick a radar product, obviously the color scale changes here at the bottom. So now we've covered the reflectivity. Let's go over to some other products that we have in the ChaseBuddy. So guys, let's now switch over to satellite. Currently, we only provide two types of satellite imagery, namely geostationary satellite imagery and polar orbiter satellite imagery. For the geostationary satellites, we provide the following products, namely a basic infrared, a water vapor imagery, which is colored internally by us. We provide, there is a infrared RGB product, a visual RGB product. Currently, as you can see, nighttime has already set here over Europe, but on the left, you can see how the visual product still looks like. We have the convection RGB product, a lifted index product, which is a measurement of the instability throughout the whole atmosphere. We currently also provide a rapidly development thunderstorm product, which shows where rapidly development vertical cloud formation is happening currently. For the polar orbiters, we provide the METOP B and the METOP C scatterometry imagery. Let me show you what that looks like. These are actually bands that the polar orbiters generate and provide wind speeds measured over water body surfaces. If you would like some more information about all these products, don't hesitate to put something in the comment section. I will be happy to create a new video explaining a few of these concepts. Maybe I will create a whole playlist on satellite meteorology as well. Just drop a comment in the comment section whether you would like to see that or not. Okay? So these are currently the satellite imageries. As you can see, you can overlay as much as you want here. You can overlay, for example, the infrared, put the water vapor on top of that, put the rapidly development thunderstorms on top of that, and you have actually a very good picture of what's happening inside the troposphere, where all the action in the meteorology, or all the action that we experience rather, on the surface in meteorology happens. So a severe weather monitoring application having radar and satellite is already something, but everybody monitoring thunderstorms and such would like to see some metrics on around lightning, right? So what we also added is we added a indication for when live strikes are happening. You can see them visualized on the map. We have a lightning history, we have an activity area, and we have an outline area. Okay, let me see whether, here, there are some thunderstorms happening here in the central part of the UK. So we have the live lighting, the history, the activity area, and the activity outline. This contour here is actually generated by a system that we have created ourselves. So we capture all the lightning, we run a clustering algorithm on top of that, and it actually shows you thunderstorms, right? This is already something. There's a lot of products that already show this, but what's unique in the ChaseBuddy is we provide not only that, but we provide lightning metrics per storm. You can see a trend in lightning count. You can see a trend in size as well. The more lightning a storm produces over time, the more the trend will start to say so that it's actually strengthening, stagnating, or weakening, right? We have the same here in the size. A storm can grow or shrink in size. You will have a indication there as well. You see how old the storm is or how long it produces lightning already. You have the lightning count, you have the lightning rate or the flash rate, you have the direction where the storm is moving to, and you have the storm speed. Okay, now this is actually a unique product. Even like the big players, they do not provide these detailed metrics. Okay, on top of that, you also have not only that, but we have a storm tracking algorithm as well, which is based on clustering algorithm as well. If you turn on these ones, the storm extrapolations and the deviant motion detection, you can actually see that this contour is being extrapolated in the future, right? As you can see here, which means that you actually have an indication of where the storm is heading in this direction and at this speed. Each contour has its own storm metrics, which is, again, this is a very unique product and you don't see this anywhere. This is the only app which provides these types of metrics. All right, so for storm chasers and for weather enthusiasts, this is a must-have. Every storm has these extrapolations, right? And a trend. As you can see, they also show like a small graph where you have the area, right, over time, the lightning count over time, the flash rate over time, and the density in flashes per 10 kilometers squared over 10 minutes. Okay? So this is the lightning. Okay, so now we've covered the lightning. Let's go over to the next entry in our list here, which is the model data. Now, as you have already seen by now, probably the ChaseBuddy is not a forecasting app. You don't really do your forecasts with it. It's only an application which focuses on nowcasting, right? What is happening now? What does the radar look now? What does the precipitation look like? Where is the precipitation moving towards? What's the global picture with the satellite imagery? How does the lightning behave? How does the storm behave? Where are the storms moving towards? There is some model data in the app, which we will go over next. But the model data is only there to reinforce what you see on satellite imagery. So you can actually correlate what's happening with the model data. Okay, still 4 topics to go over, which is the model data, the observation, space weather, and the shooting locations. Let's go over those topics right now. Now, when we start to consider the model data, the real model that you use isn't really important. You would say, why is that? Well, think about it. Model data like the GFS or the European model or the ICON or whatever model that you prefer or that you are a fan of, the current day or one day ahead, they don't really differ all that much in terms of performance. Most of the models, they look more or less the same. And since we're not doing really forecasting, right, and the divergence between the models only start to happen like a few days in the future, we're not really that concerned with which model we use. So currently we are using the GFS model to corroborate our picture or to reinforce our picture. We currently have the following products. We can visualize the 10-meter wind streamlines, where you can see here there's a low here. Judging by the satellite picture, there's an occluded front here, moving like this with the warm conveyor belt of the system to the east-northeast. Okay. We can overlay the pressure field in there, which, as you can see here, there is indeed a low pressure area there. You can add the pressure at 2 PVU to look at it from an isentropic perspective. You have your 500 millibar heights and you have your 500 millibar isotax greater than 50 knots, right? If you zoom out a bit, you actually have a clear visual on how all the players are working together to produce the weather over Europe currently, right? There's also a cyclone track or a tropical cyclone track and a tropical wind speed probability. But as you can see here, there's no really a tropical cyclone currently over the Atlantic, so I can't really show you that product, but it is there. You can reinforce the model data actually currently with also the observations. Let me erase this actually. Let me turn off the radar. If you turn on the observations, for example, you can see the METARs over Europe. Currently, there is a gap here. Why? Because there is a problem with the APIs that we use. Some METARs are not coming through by now. We're going to look at how we can circumvent this. Currently, we show the temperature. We show the dew points, right? And we show the dew point depression. Okay, there's also here a color fill of CAPE, which we augment with the surface observations to produce our own CAPE calculations. All the rest is still coming from the GFS model, right? But we augment the lower levels with the observation, so we have a better indication of what the instability is, or the CAPE, the convective available potential energy is right now, right? And as you can see here, along the Dutch coast rather and the North Sea, there are some patches where there is some slight CAPE available, right? Which might lead to potentially some thunderstorms. So we now covered the model data and the observations. Let's shift a little bit gears into the space weather and then the shooting locations itself. Okay, let's see you there. Next up, we have the space weather section where we visualize the probability of the northern lights happening or being visible. The data is coming from the NOAA, and it actually visualizes the chances of seeing aurora borealis or the northern light, and the chance is in percentage. There are many visualizations floating around here in different apps in different manners, but what's unique in the ChaseBuddy here is we added range rings, and we added two types of range rings: a range ring for the green aurora and one for the red ones. And you can see that they are provided in degrees of 10, 25, and 45 degrees up. So how you actually interpret this, say you are at a given location, right? And you look 10 degrees up, and if the range ring for the 10 degrees up in elevation intersect here with the probability of the aurora, this means that at this elevation, 10 degrees, there's like this many percent to see the red aurora hues. The same for the green. If this green range ring intersects a section of the aurora borealis, this means that you would have that much chance that you can see the green aurora. If you turn on the range rings and such will be tied to your GPS location. So be sure actually to enable that here. Now, next up here, as last one, we have the shooting locations. And this is also a feature that I'm actually quite proud of. So what you can do is you can enable the shooting locations, and shooting locations are actually locations where you can find locations where you have a good view of thunderstorms to create your time lapses or to take your pictures or do whatever you want, do a live stream, do whatever, right? And if you tap on one of the shooting locations, you get a notice here, right? Where it is, where it's located, and you have two functionalities here. One functionality is to preview that location in Google Street View. You can all do that in the app, right? What you can also do is the following. There's a button here, and provided that you have Waze installed on your device, okay, and you have Android Auto or Apple CarPlay installed in your car or available in your car, the moment you tap on that location, it will automatically navigate your car towards that shooting location, which is a very neat feature which you can't find anywhere else as well. And there's a button here in the bottom left. I can't show you this right now on the website. What would happen is if you tap on that button, you get a message popping up saying that you can add shooting locations right now, and you can add a shooting location by taking a picture on your phone and you upload that shooting location. You would have a new shooting location which will be available to everybody in the community that will use the app. And it makes the app a little bit community driven, that all the people using the app for their storm chasing operations can add shooting locations that other people can use too, to take pictures whenever they want and perhaps meet each other there. So this is also a very unique feature, especially the feature to navigate your car directly through the app. You don't need to have another application. Again, it's all in the spirit of collecting as much functionality and making it available in one application. And that's the ChaseBuddy. This is what I've been building behind the scenes. And now you can actually finally see why I've been absent for so long on YouTube. The app is already available on both Android and iOS, and above all, it's completely free. In the future, the ChaseBuddy, as I already mentioned, will also be used to survey meteorological situations, to document events, potentially even do a live session here on the channel. It will also form the basis of every forecast and explanation and or deep dive that I will bring to all of you. Okay. Also, if there's a topic in this video that you might want a dedicated deep dive on, whether it's satellite meteorology, how radar works, potential vorticity, some model data, or even the fundamentals of meteorology, just let me know in the comment section and I'll think about making a video of that as well. And if you just want to follow along with the development of the ChaseBuddy or any other meteorological content that will undoubtedly come in this channel, be sure to subscribe and be notified whenever new content comes up. Okay. Thanks for watching, I would say, and I'll see you in the next one. Bye, everybody.